Okay, so in an explicit manner, uh, so so in an explicit और mathematical sense, अगर आप compute करना चाहते हैं, that is the total probability. That is the total probability से मुराद है computing over sum over A, all the eigen observable A. देन जो आपके पास प्रोबेबिलिटी की इक्वेशन हमने ऊपर लिखी थी, हम इसको एक्सप्लिसिट में इसकी यानी इसकी राइट हैंड साइड को, जो कि बुनियादी तौर पर मॉड स्क्वायर्ड वैल्यू है, और मॉड स्क्वायर्ड वैल्यू बुनियादी तौर पर क्वांटम मैकेनिक्स में इज रिटन एज द स्केलर प्रोडक्ट ऑफ द स्केलर प्रोडक्ट विद इट्स कॉम्प्लेक्स कॉन्जुगेट. सो हम एक्सप्लिसिटली अगर उसको लिखना चाहें तो हम कुछ यूं भी लिख सकते हैं, दैट इज इन एन एक्सप्लिसिट और मैथमेटिकल सेंस, इन किधर गया कर्स, इन और मैथमेटिकल मैनर, मैनर computing the sum over A, over A, that is all observable of P of A comma T, that can be written as P of A comma T, but we are basically summing over A, sum of all observable, yeah, which is equals to the sum over A. And now we write that mod square value explicitly as the product of the scalar product with its complex conjugate. So we have the scalar product psi of comma T A into A psi of T, this quantity. This quantity here is basically the projection operator. Yeah. So this is basically what we have written here is in fact and explicitly the squared value. Yeah, जो absolute value आप ऊपर आपने probability of this square of the absolute value लिखा है, इसको आपने explicit form के अंदर open करके लिख दिया. Yeah, that is the sum over all A is the projection operator which is equals to 1. Yeah, so is the that इसको हम यूं भी कह सकते हैं कि ये जो क्वांटिटी इज इन फैक्ट इज द सम ओवर ऑल ए is the is the projection operator is equal to 1. सो अगर इस प्रोजेक्शन ऑपरेटर को आई ई, दैट इज सम ओवर ए, this is equals to 1, then we have this total probability is in fact equals to the square. Yeah, so this is this is nothing but the norm, but the norm of the wave function. बिकॉज अगर आप प्रोजेक्शन ऑपरेटर को सम ओवर ए प्रोजेक्शन ऑपरेटर इक्वल्स टू 1 करेंगे, वो किसके बराबर हो जाएगा? दैट इज नथिंग बट द नॉर्म ऑफ द वेव फंक्शन. एंड व्हेन वी से इट इज जस्ट द नॉर्म ऑफ द वेव फंक्शन, इसका मतलब क्या हो जाएगा? दैट इज समीशन ओवर ए ऑफ पी ऑफ ए कॉमा टी देन दिस वुड बी इक्वल्स टू, अगर आप इसमें प्रोजेक्शन ऑपरेटर इक्वल्स टू 1 कर दें, तो दैट वुड बी साई कॉमा टी, साई कॉमा टी, एंड दिस इज नथिंग बट इक्वल्स टू किसके बराबर, 1 के बराबर, है ना। सो ये आप, इनफैक्ट आपने यहाँ पर ये साबित कर दी। सो दूसरे लफ्जों में हम वी स्टार्टेड विद सेइंग दैट the wave functions are unit normalized, yeah, for describing that unitary operator is this operator u is, or the time evolution operator is a unitary operator, that it preserves the scalar product. Then we started with saying that it is unit normalized, and then we find we obtain the total probability, and this total probability is coming equals to किसके बराबर, 1 के बराबर. So this implies, and if it is coming equals to 1, then इसका मतलब क्या है, it is unit normalized. So the statement that the wave function is unit normalized is just the statement that the sum of all probabilities is equals to 1. Yeah. So अगर आप ये स्टेटमेंट दे रहे हैं, दैट इज, ये हमने कहा इसके बारे में, ये हमने इसके बारे में कहा द वेव फंक्शन इज यूनिट नॉर्मलाइज, देन इसका दूसरा मतलब क्या है, दैट द सम ऑफ ऑल प्रोबेबिलिटीज इज इक्वल्स टू 1, एंड that is the basic state of any dynamical system must obey. So in fact, whenever you talk about unit normalization, then we say that any dynamical system must obey this unit normalization property. Yeah. So one would say, so इस चीज को, यानी ये जो इक्वालिटी हमने लिखी है, इसको हम कैसे कह सकते हैं? So the statement that the wave function is unit normalized, is unit normalized, is just the statement that the sum of all probabilities, sum of all probabilities is equals to 1. Yeah. So this is basically the statement, and this property that the sum of all probabilities is equals to 1, which is equals to the unit normalized statement, then this property has to be obeyed by all dynamical system. That is the state basic state of any basic state or fundamental state of any uh, dynamical system must obey. This is something which is which is important. So then the property of the system must have, in order to maintain some sort of unit normalization property. And so we basically are saying that this operator, U operator, or the time evolution operator, is a unitary operator. Yeah. So if uh, psi of t is equals to unitary operator t comma t prime, that is, the system evolves from earlier time t prime to some later time t, uh, psi of t prime देन इसका मकसद ये हो गया कि we need to compute the norm of the psi of psi comma t, that is that ket vector, and compare that norm of psi comma t prime, and this will give how the norm changes as a function of time according to this equation. Therefore, by definition, the bra vector of psi of comma t, that can be written as the same equation as what we have written for the ket vector. And when we multiply these bracket vector, we again come to this unit normalization property. So then, uh, so then computing the norm of psi comma t and compare the norm, and when you compare the norm of psi comma t prime, and this this will in fact give how the system uh, the how the norm of the system changes as a function of time, as a function of टाइम. सो अगर हम इसको लिखें ब्रा वेक्टर को, सो साई कॉमा टी is can be written as psi comma t prime, sorry, this is, then you write dagger of t comma t prime, then which is basically the definition of the adjoint of the Hermitian conjugate. Yeah. So U dagger is the definition of the adjoint or the Hermitian conjugate of U. Yeah. So if the state remains unit normalized at all times, that is, if the state remains unchanged. Yeah. So then if you say so, if the state remains unit normalized at all times, so then what you do, you take the uh, product. Yeah. So you take so if you take the product, so that is basically psi of uh, t, psi of uh, t prime. Yeah. यानी दूसरे लफ्जों में, इफ दिस इज इक्वल्स टू वन, इस स्टेटमेंट का मतलब जो हमने ऊपर लिखी है, सो इफ दैट इज, यानी this statement is basically this. So this is, so this statement is in fact, this statement is written in this manner. Yeah. So if you plug in the values of this psi of comma t in इस equation के अंदर, so आपके पास क्या हो जाएगा, this is equals to 1 and this equals to 1 is psi of bra vector की equation लिखें, so that is psi t prime u dagger, and ket vector की equation लिखें, which is u psi of t prime. Yeah. And so this this is equals to 1 if and only if uh, this quantity is equals to 1. Yeah. So इसका मतलब है कि we said and then if the state is unit normalize at all times, then U must be unitary, must be unitary operator. And what does this imply? That is U dagger U equals to 1 के बराबर होना चाहिए, ठीक है ना? सो अगर और ऑल्सो और u dagger equals to 1. So either you could write u dagger u equals to 1 or u dagger equals to 1. So for this that is for this to be equals to 1, जैसे कि यहाँ पर ऊपर आपने लिखा है, then this is only true if u is a unitary operator. And by saying that u is a unitary operator, इसका मतलब है u dagger u equals to किसके बराबर होना चाहिए? Equals to 1. And being called as unitary operator means that the conservation of probability. So एक और यहाँ से बात पता चल रही है कि जब हम इसको ये कह रहे हैं कि it is in fact a unitary, then इस unitary का मकसद ये हो गया कि we are not only in fact observing the fact that the states are unit normalized, but we are also observing the fact that the unitary operator is also implying that the probability is conserved. That is, time evolution operator takes in unit normalized state to unit normalized state. That is, when it makes a transition from in time, that is from t prime to t. So it starts with unit normalized state and ends into a unit normalized state. Yeah. So we would say being uh, being called as unitary operator means the the conservation of probability. That is, the time evolution operator takes in unit normalized state normalized state to unit normalized state. प्लीज वेट कीजिए. So, so we say it's to unit normalized state. Yeah. Okay. So this proves that the operator, this linear operator, is a unitary operator. Yeah. So it's a very important or interesting, although it takes not much time, but it's a very important property, that why we call it as unitary operator. So if you trace back, then you can trace the fact that how we have basically come up with the idea that this linear operator is unitary operator, by just in fact identifying the fact that we talk about in quantum mechanics, we talk about unit normalized state, and that unit normalization can be associated with the total probability of some eigenvalue. Yeah. And that is then related to this concept. There are other properties as well. So other properties may hum the product of two unitary operator, one going from time t is equals to t1 to time t is equals to t2, the other going from time t2 to t3. The product of two unitary operator could be is equals to a unitary operator where the system is taken from time t is equals to t1 to time t is equals to t3. So अदर प्रॉपर्टीज जो हैं वो क्या हो सकती हैं? अदर प्रॉपर्टीज ऑफ unitary operator could be something where you have this unitary operator taking a state from T1 to T2, and there is another operator taking the quantum state from T2 to T3, is equal to a unitary operator which takes the system from time t is equals to t1 to time t is equals to t3. Yeah, so this is another property. So a time evolution operator, there is another property, a do nothing operator. So there is a time evolution operator which does nothing. That is when we transform time t is equals to time t, then it is equals to 1. So do not involve, so the operator is equals to 1. Yeah. So एक प्रॉपर्टी तो ये हो गई. एक और प्रॉपर्टी, a time evolution operator which does nothing, and is of the form, कैसे लिखेंगे उसको? हम यूं लिख सकते हैं. सो अ टाइम ऑपरेटर विच गोज फ्रॉम टाइम t इज इक्वल्स टू t, कोई प्राइम नहीं है, कोई सबस्क्रिप्ट नहीं है, देन दिस इज इक्वल्स टू 1. या डोंट इवॉल्व in time, evolve, so evolve in time, so is equal to 1. Yeah, so this is some property, और इन दो प्रॉपर्टी का अगर हम इस्तेमाल करें तो we can sort of define the property of adjoint which is equals to dagger. Yeah, so using these two properties, so one could write a unitary operator in going from time t1 to time t2 is same as time u from going from time t1 to t2, and then reverse, which is sort of an inverse, and this inverse is basically an adjoint. So u of t2 comma t1 is represented by dagger, which is the adjoint of u, unitary operator. So this is basically, in fact, the definition and properties of a unitary operator. Now we want to relate the time evolution operator with the Hamiltonian. What is the relationship between the time evolution operator and the Hamiltonian? So let us talk about a relationship between uh, unitary operator or time evolution operator and Hamiltonian. This is what we want to describe here. So let's start with the, so this is something, an article. So let's start with the Schrodinger equation. So since the time dependent Schrodinger equation that can be written as d by dt psi, which is equals to that psi. So हम यहाँ पर वो नहीं लिख रहे हैं एच बार या एंड देन द टाइम एवोल्यूशन ऑपरेटर कैसे लिखा जा सकता है एंड द टाइम एवोल्यूशन ऑपरेटर फार्मूला वो क्या हो जाएगा आई ई दैट इज psi of ket vector which is equals to unitary operator u t comma t prime, and this is equals to psi of t prime. Yeah, so this is in fact these two equations, and we want to relate the Hamiltonian here with this unitary operator u. Yeah, then one could take the derivative of this equation, ये जो आपने time evolution equation लिखी है, और अगर आप डेरिवेटिव लें on both side, then it will it and then we would compare it with the Schrodinger equation, and this comparison would give us the relationship between the Hamiltonian and the time evolution operator. Then one can take the time derivative of the above equation or time evolution equation, और क्या हो जाएगा, so that would be d by dt psi t which is equals to u dot. So this would become u dot t comma t prime and psi of t prime, and then we compare it, and then comparing it with the Schrodinger equation gives a relationship between h and u of t comma t prime. Yeah. Yeah. So one could then basically have the relationship. So let's compare these two, और फिर उसके बाद relationship निकालते हैं. So what we have here is in fact, so you see we have the differential equation, sorry, time evolution equation का जो derivative हमने लिया है, we have this differential equation as in time t. Yeah, so we could think about writing on the right hand side, which is basically this quantity, using this equation, that is using this equation, या so हम इसका इस्तेमाल करते हुए, इस इक्वेशन का इस्तेमाल करते हुए हम इस इक्वेशन को, जो कि हमारे पास यहाँ पर ये इक्वेशन है, d/dt psi comma t, this can be written as u dot of t comma t prime, and then इसकी जगह, that is using this quantity, this cat vector की जगह हम क्या लिख सकते हैं, u of t prime comma t psi of comma t, yeah, so using the equation जो हमने ऊपर लिखी थी, but you see we want to go from time t. So here when we write this psi of t comma psi t prime cat vector in terms of psi of t, then we are moving from initially we go from time t to t prime. Now we are going from time t prime to t, that is in the reverse order. Yeah. And so we have this equation, and इस equation के अंदर हम इसको in terms of adjoint भी लिखा जा सकता है अगर हम उसको change कर दें. So we have psi comma t, this is equals to u dot of t comma t prime, and if you revert this order of time, then you can write it as u dagger of t comma t prime psi of psi comma t, yeah, cat vector. And now you can compare with Schrodinger equation. So comparing with Schrodinger equation, you get, you have iota h bar d by dt psi comma t, which is equals to h psi comma t, and you now compare these two equations. That is which equation? Uh, this equation with this equation, and when you compare it, you get h is equals to iota h bar u dot and u dagger. Yeah. So if u is unitary, then this would imply that u into u dagger 1 के बराबर होता है. So let's say हम देखें, so if u is unitary, अभी अभी कंपैरिजन कंप्लीट नहीं हुआ, हमें इसको डैगर हटाना होगा. यूनिटरी, इसका मतलब क्या है? इसका मतलब है यू यू डैगर 1 के बराबर होता है. और अगर मैं इसका टाइम डेरिवेटिव ले लूं, टेकिंग टाइम डेरिवेटिव, सो टाइम डेरिवेटिव का मतलब होगा यू डॉट यू डैगर प्लस यू डॉट डैगर equals to 0. Yeah. Or you can always write this equation as u dot u dagger plus, हम इसको लिख सकते हैं u dot u dagger dagger इक्वल्स टू 0. अगर दोबारा करेंगे तो वही आ जाएगा. डैगर अगर अंदर मल्टीप्लाई होगा ब्रैकेट के, तो डॉट पर डैगर आ जाएगा, और डैगर डैगर ऑफ डैगर इज इन फैक्ट यू. या सो इट मीन्स, इसका मतलब ये हो गया कि u डॉट u डैगर इज एंटी कम्यूटेटर, क्योंकि यहाँ पर क्या चीज़ मौजूद है? प्लस साइन मौजूद है. ठीक है ना? सो इट इज एंटी कम्यूटेटर. इन ऑर्डर टू have it so for to make it Hermitian, we need to write it as a commutator. So how do we do that? We take the adjoint of some complex quantity, which is, if we take the adjoint of a complex quantity such as iota, then it would change from plus iota to minus iota. So taking its adjoint will change its sign from plus, from the positive to negative. So if it is multiplied by iota on the left hand side of this above equation, जो टाइम डेरिवेटिव आपने लिया है, by iota, and then you would have the Hermitian operator, which is iota u dot u dagger equals to 1, which is the Hermitian operator. So this would mean this means that u u dot u dagger is anti-Hermitian. Anti-Hermitian. Yeah. So taking its adjoint will change its sign from positive to negative. Sign from positive to negative. So if if we multiply, so if it is multiplied by iota, which is a complex quantity, one obtains a Hermitian operator. One obtains a Hermitian operator. Hermitian operator. Yeah, and this is I u dot u dagger is Hermitian because it would change its sign from positive to negative. Then दूसरे लफ्जों में you would say that iota h bar u dot would be h u. Yeah. Then then one obtains iota h bar u dot is equals to किसके बराबर hu when you multiply it by the by iota. Yeah, and that would change it to so solving Schrödinger equation is equivalent to solving this differential equation. यहाँ से आपको ये पता चल रहा है, ठीक है ना? So you could use the Schrödinger equation for time evolution, or you can use this equation. So दूसरे लफ्जों में you can say, so solving Schrödinger equation is equivalent to solving this differential equation, which is which determines which determines u operator, that is unitary operator, the at finite time in terms of Hamiltonian. Okay, uh, it happens sometimes. हम ये भी कह सकते हैं कि sometimes one could say that Hamiltonian generates infinitesimal time evolution because it tells us the differential equation obeyed by the wave function. So not only you could